Hello, everyone. In this section, what you guys are doing is you have three sides and three angles in a triangle. So there's 6 pieces of information, 3 angles, 3 sides. You're always going to be given half the information. In this case, you're given 2 sides and 1 angle. Now, you may say the right angle doesn't really count, but what you use this right angle for is that the SOHCAHTOA stuff still works. Next semester, you can't assume it's a right triangle, so SOHCAHTOA, there are different options that we have to use because they're non-right triangles. So here goes. You're still going to do the Pythagorean theorem. You're still going to find the missing pieces. So 6 pieces, you told half, you got to find the remaining 3. In this case, it's 2 angles and 1 side. So the Pythagorean theorem still holds. Remember, this side is side A, this side is side B. So filling in what you got, 1 squared plus b squared. I really don't need to show you guys this. 2 squared is 4. Subtract the 1. B squared is 3. So b is the square root of 3. Alright, so this side's the square root of 3. So you would make a list. B equals square root of 3. Okay, it's not plus and minus because it's just a length. So it's just the plus. Now to find the missing angles, a suggestion I would give you guys is always use the information that you're told on the off chance that you screw this up. If you screwed this up and it's not actually the square root of 3 and you use it to find the angle, then your angle's automatically wrong. So try and stick to what you're told on the off chance that's a mistake. It really doesn't matter which angle you stand on first. You already know C, so don't bother trying to find it. It's a right angle. I'll just stand on A first, being alphabetical. If I'm standing here, I'm told the opposite and the hypotenuse. That's sine. Sine of A is going to be a half. Now, you guys know from the unit circle, where is the y value of an angle? A half. Well, in case you need just a quick little review, half for y value is going to be there at 30 degrees. So A is 30 degrees. Now I'll show you how to do it on your calculator in just a second, but here goes. Because it's a right triangle, we've talked about that angle A and angle B have to be supplementary, complementary. You can just take this angle and subtract it off of 90 and get this one. But with the warning, if you screw up this angle and you do that, then automatically this is wrong. So what is the alternative? What am I suggesting? I'm suggesting that you stand on the other angle and say, hey, I got the adjacent, I got the hypotenuse, so that's going to be cosine. Cosine of that angle is a half. You look back at the unit circle, where's your x value? A half. It's going to be up there at 60 degrees, so B is 60 degrees. Okay, I know it sounds like it certainly is more work. I'm just offering that up as a suggestion. If you screwed this one up, then automatically that's wrong if you cut it off at 90, so be careful. Alright, I was saying, you're not very good at the unit circle. How else do you solve that? Well, as an analogy, as a comparison, if I gave you guys x squared is 17 and I ask you to solve it, you're going to do something to both sides that undoes that function. Well, here, what you're going to do to undo sine is called inverse sine. I know this notation makes it look like reciprocal, but it's not. I'm going to take the inverse sine of both sides. Sine and inverse sine cancel out, and I have A is equal to inverse sine of a half. And you type that in your calculator by going second, hit your second button, sine, and then a half. And if your calculator is in degrees, it's going to return 30 degrees. If your calculator is set in radians, then you're going to get some funky decimal. Somewhere around 0.5 would be your answer, somewhere near 0.5. So if you need to change the calculator into radians, go second, whoops, wait a second, nope, just mode, scratch that, just hit mode. Yep, just hit mode. It's next to the second button. Scroll down and highlight degrees and hit enter. Okay, so it's through the mode button. I wish I could call the stuff up here on the calculator, but I can't. So here goes. Next one. Sorry, on the computer, not calculator. All right. Going to do the Pythagorean theorem. That's the hypotenuse. So you got 9 squared minus 1 squared is, in this case, a squared. Set side A. So that would be 8 is a squared. So then you square root both sides. And yes, you have to reduce them. So that's 2 square roots of 2 is a. Okay, and I'm a knucklehead. Okay, I'd love to blame it on the cold medicine I'm on, but I don't know if that's really going to be the case. This is side B, and that's what you're... Yep, this is true. That was side A. Absolutely. But that's not what you're solving for. Okay, as long as you can laugh at yourself, I suppose everything's all right. Yeah. Okay, so that's side B. Okay, here goes. So that's side B. 2 squared is 2. So you make a list. B is equal to 2 squared roots of 2. So you have to find angle A, and you have to find angle B. Okay, trying to push through this. Standing on this, what you know is you know the opposite and hypotenuse. If I want angle A, so again, that sine of A is your opposite over your hypotenuse. I have no idea where the y value is a third, so that's definitely a calculator question. And you guys are okay if you round your answers. How about to the nearest hundredth? Okay, so you would inverse sine both sides. A is equal to inverse sine of a third. Type it in your calculator and see what we get. So inverse sine of 1 divided by 3. Oops, hit the wrong button. Apologize, guys. And it looks like it's about 0.34. Whoops, my calculator's in radians. Yes, it is. So let me change it to degrees. And it looks like it's about 19.47 degrees. So I'll just write it here, 19.47 degrees. Okay? Yes, like I said, you could just cut this off at 90, but being thorough, I'm going to stand here. I know the adjacent, I know the hypotenuse, that's going to be cosine. So the cosine of B is equal to a third. Yikes. Inverse cosine both sides. B is equal to inverse cosine of a third. Typing that in. Inverse cosine of 1 divided by 3. And you guys get 70.53 degrees. 70.53 degrees. If you notice, those are going to add up to 90. Okay? So, scooting along. In these ones, you knew the opposite side from angle A's point of view. This one, you're going to know the adjacent side. It really is no different, you guys. If you want more help, I can certainly do that with you. I'm going to scoot down and do these last two. Make sure you're reducing your radicals when you need to. Just saying that about the ones that I skipped. Coming here to these. So 15 squared minus 8 squared. So 15 squared minus 8 squared gives me 161. So far I'm looking at the square root of 161. But I believe that's relatively prime. When you type in the square root, you get approximately 12.68. So you need to check numbers that will divide into it up to 12. And 161 divided by 3, I don't believe works. Nope. 5's not going to work. 161 divided by 7. Yeah, that works. So that's 7 times 23, and I'm doing this on the calculator. 23 is not going to break down, so the square root of this, nothing's going to come out, so this one stays as the square root of 161. Okay, finding the two angles. I'm going to stand here on angle A, only because it's alphabetical. I'm going to start there first. I know the adjacent, I know the hypotenuse, that's cosine. Cosine of A is equal to 8 over 15. Take the inverse cosine of both sides. So inverse cosine of 8/15. Type it in the calculator. Inverse cosine 8 divided by 15. Okay, I forgot parentheses on this version of the calculator. 8 divided by 15. Okay, and I've got 57.76 degrees. A is approximately 7 degrees. I didn't round correctly. Okay, again, you could cut that off of 90, but I'd be thorough. Stand here. B, opposite hypotenuse, that's sine. Sine of B is your opposite over hypotenuse. So B is equal to inverse sine. Excuse me. So typing that in, inverse sine 8 divided by 15, and you get 32.23 degrees. So B is approximately 32.23 degrees. Okay. And that would be side A. And remember, sides are lowercase, square root of 161. Okay, so make sure you have a list of the stuff. All right. This one, the only difference is you're not told the hypotenuse. So remember, when you're not told the hypotenuse, you're going to add these things together. So you got 15 squared plus 8 squared. 289. Square root of 289 is 17. So the hypotenuse is 17. So that would be C, little c is 17. If I'm going for angle A, again, use what you're told in case you screwed this up. I know the opposite, I know the adjacent, so that's tangent. So the tangent of A is equal to 8/15, inverse tangent to both sides, 8/15. So inverse tangent 8 divided by 15 gives me approximately 28.07 degrees. Big A is approximately 28.07 degrees. So then I need to find angle B, stating here, opposite hypotenuse. So tangent of B is equal to 15/8, inverse tangent on both sides, 15/8. Yep. Okay, so inverse tangent 15 divided by 8. Yep, but it told me syntax error, so I guess I didn't put the parentheses right. Inverse tangent 15 divided by 8. Should have grabbed a newer calculator rather than this old one. 61.98. I can't even round. Good grief. It's not right. 93. There we go. Okay. All right. This is basically the end of the video. What I need to tell you on this side, this is your homework. On these first ones, you know that angle C is going to be 90 degrees. Okay? You're told an angle. Yeah, you absolutely. You guys can just cut this off of 90 degrees to get, what would that be? So if it was 30, it'd be 60, so 65 degrees? Yeah, absolutely. Now, I would suggest that you guys draw a triangle. Doesn't matter what the orientation is, which one you put A and B, but that dictates, and why I closed the 4, I don't know, that dictates who's A and who's B. So standing here, you know this is 25. Say you want side A first. Opposite hypotenuse, that's sine. So the sine of 25 degrees is your opposite side over your hypotenuse. Multiply both sides by 24 meters, or think of that you're cross multiplying, and then type it in your calculator and get a decimal. Once you know this side, you certainly could do the Pythagorean theorem, but I'm cautioning you against doing that from the standpoint of, if you made a mistake on finding this answer, then automatically what you find for side B is going to be wrong. So I'm cautioning you about using information you find to do other work. So this first side, well, these first 4, I believe, I guess it's maybe 6, it's doing just what I told you, and then the last 3 is basically the front side. So there you go. Best of luck. See you in class.